Okay, welcome. Today we're talking about parallel lines and transversals. Um, the idea here, well, there's a couple ideas that you're going to have two lines that we're going to assume are not intersecting, and these we'll call our parallel lines. And then you'll have what we call a transversal, which is the line that cuts through or intersects those two parallel lines. Think of the word trans here. It's kind of like a train, transcontinental, transportation. So it's going from one location to the next. Now, this theory and this idea of these two lines being parallel comes from these two angles here and here. And the idea is that if these two lines, let's say this are 140 and 40, if these two angle measures add up to 180 degrees, then these two lines here and here will never intersect. That if these two same side consecutive interior angles are supplementary, they'll never intersect. And then this leads into a whole bunch of angle relationships, which we'll talk about. Now, just as like maybe something else to look at, let's say we had 80 and let's call this 50. Here's two angles that are not supplementary, and if you see, if we continued these lines in this direction, you would see that they would intersect. And in order to prevent that, I would have to maybe rotate this line to where I can get it to be 100 degrees, and then we would have two lines that aren't intersecting. This is a theorem of parallel lines. Basically, if two consecutive interior angles are supplementary, then those lines that it's intersecting will be parallel. Some of the relationships that you'll see with these lines, now that we're assuming now that they don't have to be parallel, but let's look at, okay, let's say these are parallel here. I have my little parallel symbol. What we have is alternate interior angles. So if this is 110 degrees, this here will be 110 degrees. These are what we call alternate interior. They're on the interior of the two parallel lines, and they're on alternate sides. We'll call this alt-int, just to abbreviate, alternate interior lines. Now I could have two lines like this, and maybe I have this angle here and this angle here. Yes, these lines are not parallel, yet they are still, we would still consider these alternate interior angles. The difference is alternate interior angles along parallel lines, they're going to be congruent. Here, they would not be congruent. That's ultimately the difference. Going forward, I'm just going to continue to look at mainly parallel lines. But understand that we can call these angles here, we can call these here alternate interior. The only difference is because these lines are not parallel, then we would say that these angles are not congruent. And here we have our alternate interior angles. Next one to look at is we want to look at alternate exterior. So basically we have these two angles here we would consider as a alternate interior example because they're on the exterior of the two parallel lines, and again they are on alternate sides, and that's just one way. And there's always usually two. So like here and here, that would be another pair of alternate interior angles. And just like we practiced in the warm-up, if you look at this angle being, let's say, 70 degrees, and then this idea that, this is a linear pair here, so that needs to equal 180. Well, then this angle here is 110 degrees, right? Linear pair is two angles, supplementary angles that make up a straight line. Well, if this is 110, well, this here would be 110. And this angle here would be 70. And then again, you could continue on. Let's look at vertical angles. If this is 70, here is 70, and then you have your alternate interior, which makes this 70. And then you start to see that we're kind of filling out that parallel line relationship, which we've talked about. Let me make this a little bit bigger. If we have a location which has a certain set angles, let's say 60, 120 is a common one. And let's say we're driving down the street here, we got a little car, and we get to this intersection, and this is Van Ness, and we'll call this Western, and we get to this intersection, and let's say Van Ness runs parallel to Western. Basically, if I got to this intersection here, and each turn or streets make up this group of angles, it would be the same, because they're parallel, it'd be the same exact angle measures here. You'd have the same angle relationships, so that if someone else was driving down this street here and got to this intersection, they would be meeting the same angles. That's just the idea of creating angles with parallel lines and your transversal. There are a couple other ones we want to take a look at. Basically we spoke about early, those same side. We call these either same side or we call consecutive. There's two ways to talk about this. Interior angles. And these are the angles, yes, if they weren't parallel, we would still call these consecutive interior, but these are the angles that we referred to earlier, where if you had parallel lines, these two angles here would have to be equal to 180 degrees. They don't alternate sides here. You see that there's no alternating of sides, so that's why we say on the same side. And these angles are the angles that we use to keep these lines parallel. And then you have another set of consecutive interior on this side here. And those would also have to be equal to 180. And it's kind of inverted. So if this were 80, 100, this would be 180. But again, they'd be supplementary. These are our same side consecutive interior. You have which are not referred to very often, but you have the same side exterior angles that you can refer to. And with parallel lines, these will also be equal 180. And then the last one I want to talk about, if you look at these angle relationships and you have these parallel lines again, you have locations like top right, bottom right, top left, bottom left, right? If we're looking at these angle locations. And we have the same locations here, top right, bottom right, so on and so forth. And each of these angles, let's say top right, along parallel lines, the blue would be equal to the blue, right? The top right. And then you have the bottom right. These angles would be congruent as well. And then you have the top right. So basically you have same spot, what I like to say, same spot as a bottom left or bottom right, just a different location. And the word we use for that is corresponding. And so this is your example of corresponding angles here. And you can use all these angle relationships. Basically, if I were to give you, an angle measure of just one angle, if you have one angle in any of these, then you should be able to fill out all the rest of these angles here using vertical lines. Maybe you use a linear pair and you call this 150 and use this vertical, and then you have alternate exterior, which would make this 150. Maybe you have alternate interior. You call this 150. This is 30. And then maybe we use corresponding. So you'll use the 30 and say that this is 30. And basically you're able to fill out all pieces. Now, the one thing I didn't bring up, which we should talk about real quick, is that sometimes you will see the parallel lines as vertical lines and the transversal as a horizontal line like this. Now, everything stays the same. You still have your alternate interior angles. It's just you're looking at a rotated figure. You still have your, we'll say this is alt int. We'll say an example of alternate exterior would be these orange ones here. Alt exterior. It's the same relationship, but just the idea is like, here's your exterior now, and this is your interior. You just kind of rotated the shape. Here's an example of corresponding top right, top right. And then you have, let's say you have an example of same side interior right here. Same side. So it's just the same idea. You're just kind of, and maybe you want to throw in another alternate exterior. Maybe it would be here and here would be another alternate exterior. Same idea. It's just the image or the shape is rotated, and you just have to recognize that these are your parallel lines now, and this would be your transversal.